Good morning, students. Today we learn the topic colloids. A colloid is a substance microscopically dispersed throughout another substance. The word colloid comes from a Greek word kolla, which means glue. Thus, colloidal particles are glue-like substances. These particles pass through a filter paper, but not through a permeable membrane. Colloids can be made settle by the process of centrifugation. Actually, if you look into the colloidal substance, neither you can classify them as a true solution, which means all the substances are able to dissolve in a given solvent, which forms a true solution. Example for true solution is sodium chloride solution. If you try to dissolve common salt, that is sodium chloride in water, it dissolves completely without leaving any traceable matter. That is the true solution. So colloids is nothing but the intermediate substance between true solution and suspensoid. What do you mean by suspension solution? If you try to dissolve sand in a water, it forms a layer. There are some dissolvable substance which are found in sand material that is dissolved thoroughly, leaving particles behind. So there are some particles which settle at the bottom. Through filtration process, you can trace the sand solution. So you can retrieve certain substances even when you try to dissolve them. It doesn't get completely dissolved. So again, let me repeat, colloidal solution forms intermediate between true solution and suspension. We move on to next slide. The dispersed phase or discontinuous phase, dispersion medium or a continuous phase. These are the two phases which are found in any colloidal system. So normally you have a dispersed phase, that is a discontinuous phase, and a dispersion medium. So the dispersed phase particles have a diameter between approximately 1 nanometer to 100 nanometer. Such particles are normally invisible in an optical. Through their presence can be confirmed with the use of an ultra microscope or an electron microscope. It is you can visualize the colloidal substance when you pass a beam of light. You can view through the beam of light that is emerging from the other side with the presence of electron microscope or ultra microscope. Solutions. Solutions. What are solutions? When you try to dissolve a solute in a given solvent, that forms a solution. So solutions are made of particles or solutes and a solvent. The solvent part of the solution is usually a liquid, but can be a gas also. The particles are atoms or ions or molecules which are very small in diameter. Colloidal mixture. Colloidal mixture has particles that are not as small as a solution and not as large as a suspension. The particles are intermediate in size. So previously we have seen colloids forms an intermediate between solution, that is true solution, and suspension. So here the definition is given. What are suspensions? Suspensions are made of particles and a solvent. Its particle and are larger than those found in a solution. So the example given for suspension is the soil mixture. The particles in a suspension can be distributed throughout the suspension evenly by shaking the mixture. So here is the photographs which shows the difference between true solution, colloids and suspension. So in the first photograph, it is an example given for true solution. So they try to dissolve table salt in water to form a saline water. where it gets completely dissolved to form a true solution. The second one is an example given for fluor suspended in water. It appears light blue because blue light is carried off the flour particle to a greater extent than red light. The third one is milk that forms emulsion. So all suspension emulsion that forms the particle size is much larger than true solution. But when you look into the colloidal particle, the size is smaller than the suspension. So milk is an example given. Comparison of the properties of solutions, colloids and suspension. So this table that gives the properties of true solution, colloids and suspension. Particle size. When you look into the size of true solution, it is less than 1 nanometer, whereas colloids it comes between 1 and 100 nanometer. Suspension it is more than 100 nanometer. When you look into the appearance, true solution gives a clear solution, whereas colloid gives a cloudy appearance. Suspension is also cloudy in nature. When you look into the homogeneous size of the particles, true solution particle, that is the solute, dissolve homogeneously, whereas in colloidal solution, the particles are maybe homogeneous or heterogeneous. But when you look into the suspension solution, the particle tries to dissolve heterogeneously. Transparency. True solution is transparent but often colored, whereas colloid often translucent and opaque but can be transparent also. Whereas in suspension, it is often opaque but can be translucent. So when you try to separate the dissolved particles, that forms a solute, from the solvent, as far as true solution is concerned, the particles does not separate once it gets thoroughly dissolved in a given solvent. Whereas in colloid can be separated. The particles can be separated from the dissolved solution. Whereas in suspension, the particles separates or settle down at the bottom. So, whereas in true solution, when you try to dissolve solute in solvent, as far as true solution is concerned, you can pass through the filter paper, where you cannot retrieve any particle over the filter paper. Whereas colloid also passes through the filter paper. Whereas in suspension, you can easily retrieve the particles even when you pass through the filter paper. So these are the examples of colloids. So milk is given, some synthetic polymers, fog, jam, shoe polish, smoke, etc. So these are the examples given for colloids. Biological significance of colloidal system. The first biological significance is protoplasm. We know the very classical example, protoplasm is a colloidal system. And amoeboid movements, that is, we know that protoplasm shows amoeboid movements. Right? When the cell wall is degraded, you can see the protoplasm shows amoeboid movement, which is due to colloidal in nature. Fruits store a large amount of protein starch. They also exhibit colloidal properties. So as far as blood is concerned, high plasma protein forms a colloidal system in blood. The system maintains the pH and osmotic concentration of blood. Advantages of colloids. Colloids allow the dispersion of normally insoluble material such as metallic gold or fats. These can then be used more easily or absorbed more easily. Colloidal gold, for example, can be used in medicine to carry drugs and antibiotics because it is highly non-reactive and non-toxic in nature. Pharmaceutical industry makes use of colloidal solution preparation in many medicines. A wide variety of medicines are emulsions. An example is cod liver oil. Paint industry also uses colloids in the preparation of paints. In milk, the colloidal suspension of the fats prevents the milk from being thick and allows for easy absorption of the nutrients. Sewage water contains particles of dirt, mud, etc., which are colloidal in nature and carry some electrical charge. These particles may be removed by using the phenomenon of electrophoresis. The sky is the empty space around Earth and such as has no color. It appears blue due to the scattering of light by the colloidal dust particles present in air, which is said to be Tyndall effect. Asphalt emulsified. The sugar present in milk produces lactic acid on fermentation. Ions produced by acid destroy the charge of the colloidal particles present in milk, which can then coagulate and separate as curd. Soap solution is colloidal in nature. It removes the dirt particles either by adsorption or by emulsifying the greasy matter sticking to the cloth. Large numbers of food particles which we use in our daily life are colloidal in nature. Example, milk, butter and ice cream. So these are some of the examples given. From photographs you can very well see the examples given for colloids. Thank you.